Hi, I'm Ms Hearn. Let's get started. In this video, we're going to talk about how to draw inferences from two sets of samples. This is Chapter 9 in my statistics class, and we're going to go directly to Section 9.3, Two Means, Independent Samples. This section presents methods for using sample data from two independent samples to test hypotheses made about two population means or to construct confidence interval estimates of the difference between two population means. So we're looking at independent samples with sigma 1 and sigma 2, the two standard deviations, unknown and not assumed to be equal. Okay, let's look at an example. So researchers conducted trials to investigate the effects of color on creativity. Subjects with a red background were asked to think of creative uses for a brick. And other subjects, so a different data population, other subjects with a blue background were given the same task. Responses were given by a panel of judges. In other words, the judges gave them scores on who was more creative. Researchers made the claim that blue enhances performance on a creative task. So here's the data. For the red background, there were 35 data values in the sample. The mean of the data values was 3.39, so the mean of their scores on creativity level. And the sample standard deviation was 0.97. For the people in the blue background, the sample size was 36. The mean of the sample was 3.97, and the sample standard deviation was 0.63. So since we're comparing two data sets and we're talking about their means, we think we're going to use the methods from this section, and we need to do a requirement check. So the values of the two population standard deviations are unknown. We were not told that, and we're not assuming them to be equal. The subject groups are independent. The samples are simple random samples, and both samples sizes exceed 30, so all the requirements are satisfied. Okay, now let's take this same information and construct a 98% confidence interval estimate for the difference between the mean creativity score for those with a red background and the mean creativity score for those with a blue background. So again, we're looking at a difference in the means. So you're going to look on your formula sheet and you're going to look for Chapter 9 confidence intervals, two populations. Look down where sigma 1 and sigma 2 are unknown and not assumed to be equal. And we see that we have formulas for the error and for the confidence interval there. So here's where we calculate our error. The error is equal to t sub alpha over 2 s1 squared over n1 plus s2 squared over n2. Remember, we found t sub alpha over. So for t sub alpha over 2, since we have a 98% confidence level, so whenever we're talking about confidence intervals, if we have a 98% confidence interval, then what we're saying is that we're looking at having 2% left over. You can think of it as 1% on either end. So in other words, we're thinking of in terms of two tails. In two tails we have 0.02. In one tail we have 0.01, 1%. So we're going to still be looking at a degree of freedom of 34, and we're looking in the same column. So you're still going to get, for your t sub alpha over 2, right, t sub 0.02 over 2 or t sub 0.01, you're going to get that 2.441 again. And then we're going to plug in our other values. S1 is 0.97, S2 is 0.63, N1 is 35, N2 is 36. Please practice doing this calculation on your calculator. Remember, you're taking the square root of the whole thing, so depending on how you enter it in your calculator, you might need to put everything in parentheses. And you might need to put each fraction in parentheses as well as the whole thing in parentheses in order to make sure that your calculator does the correct order of operations. And you should end up with 0.475261. This is your error. Okay, so plugging into our confidence interval formula, which we find on our formula sheet, we are going to have to subtract x1 minus x2, the difference in the means. And remember, x1 is our 3.39, x2 is our 3.97, so the difference, x1 minus x2, is going to be negative 0.58. And now we need to take that number and subtract the error. So that's negative 0.58 minus 0.475261. And that's where we get the negative 1.06. You're going to do the same thing on the other side, but add the error to it. Okay? And then that's going to result in negative 0.10. So this is a confidence interval for the difference in the means. So we're 98% confident, if you want to say it that way, that the difference in the means is between negative 1.06 and negative 0.1. And that should be a negative 1. So we're 98% confident that the limits negative 1.05 and negative 1.0 actually do contain the difference between the two population means. Because those limits do not include 0, our interval suggests that there is a significant difference between the two means. In other words, that we don't think they're equal. So that concludes section 3. The next section that we'll be covering in class is going to be section 9.4, 2 dependent samples, matched pairs. I hope you found this video helpful. If you did, please remember to like it because that will help other students to find the video.